So for Unit 8, transformations and constructions, we first need to define what a transformation is. Another word for transformation is mapping, or actually let's say a mapping. That results in a change in the position, shape, or size of a figure. Okay, and our example, we're going to do a, let's do a triangle. So let's say, here's my triangle. And let's say I flip it upside down. So if I flipped it upside down, it would look like this. Okay, so that's a transformation. I took the same shape and I changed the orientation, the size, or the position of it. So that's a transformation. So it's kind of the blanket term, and then we're going to be learning about different kinds of transformations. Okay. Another vocabulary that we need to know is when we're doing a transformation, we have what's called the pre-image and the image. So the pre-image is the original figure of a transformation. So in our previous example, the pre-image would be the first one, the one we started with. So it would be this triangle. Okay? So that's the pre-image in our example of the previous one. So if the pre-image is the original, the image is the resulting figure in a transformation. Okay, so in our first example, the image would be this triangle. Okay. So we're going to talk about one particular type of transformation, and that is a translation. So there's many different types of transformations we're going to talk about. Today we're just going to talk about a translation. So a translation is a transformation It's okay. That maps all points of a figure the same distance in the same direction. Basically, we're going to take an image or a pre-image and slide it around without changing the orientation or anything. So we'll do maybe slide it left 3 spaces, or right 3 spaces, or up or down. So let's say I give you, let's do the same triangle, and we want to translate it to the right. So that means it gets moved, exact same triangle, to the right. Nothing changes except the position. Okay. Okay, so when we are talking about transformations for you guys, we are only going to talk about what we refer to as rigid motions. So the first key concept for you guys is rigid motion. Rigid motion means a transformation that preserves distance and angle measure. Basically, a rigid motion is a transformation that does not change the size or the shape of whatever your pre-image is. So we can flip it around, and we have like a domino kind of example. You can flip it, so that first one is the back of the domino, and then the part with the dots on it. So you can flip it. You can slide it around, or you can turn it or rotate it. But those are the only rigid motions that we can do. So a rigid motion is a transformation that does not change the size or the shape. So those are the transformations we are going to be working with. So what we are going to do for the very first 3 questions is it a rigid motion or not? So let's look at number 1. There's your pre-image and your image. Does it look like it's the same size? Yes. Does it look like it's the same shape? Yeah. What does it look like they did to it? They just flipped it. So flipping is a rigid motion, so we would just say yes. And then we're going to do these together. So number 2, guys, is it a rigid motion? Yes or no? No. No. What does it look like they did on that one? They shrunk it. And then number 3, rigid motion, yes or no? Yes. Yes. What does it look like they did there? They slid it, and what else? It looks like they flipped it, right? So they flipped it and they slid it. Okay. So notation for transformations. So there's 2 different types of ways we can describe a transformation. This one that is shown is just, it looks like a flip, so they flipped it. So here's your pre-image. Let me just outline it for you guys. There's your pre-image, and then here's your image. And what those dotted arrows are showing is the corresponding points. When we do perform a transformation, there are 2 ways that you can note it. So in this triangle, I have triangle JKQ, and then they flipped it and they renamed it J with a little apostrophe, which in math we call that prime. So this is J prime, K prime, Q prime. So we can't use the same name for the points because they're not the same point, right? Like wherever J is here, I can't name this one J because it's not in the same spot. Does that make sense? So we have to give it a different name. So usually we call it J prime because that tells us what the original point was, and the prime means that I translated it, or I flipped it, or I moved the point. Sometimes in transformations, we just give them completely different letters. So we could have also called this MNO, okay? So you could also give them different letters. Prime is usually the most typical, but sometimes we just do different letters. In arrow notation, that just means it's like mathematical language. So this is saying triangle JKQ, and that arrow means maps or transformed. into triangle J prime, K prime, Q prime. So in math language, that arrow means maps or transformed. So we can use arrow notation. Or we can just write it in words. Triangle JKQ maps onto triangle J prime, K prime, Q prime. So in words, you can also write it out. Something to note, when we always list corresponding points of the image and pre-image in the same order. So I list it as triangle J prime, K prime, Q prime, because those are the points that correspond to the original image. So we list them in the same order, okay? So we're going to practice that in the next example, and we're going to do the first one together. So we're going to name the images and the corresponding parts. So I'm going to do the first one with you guys. So this, 1, 2, 3, quadrilateral, EFGH maps to E prime, F prime, G prime, H prime. So let's first list the corresponding angles. I'm going to start with angle E. Which angle corresponds to angle E? So here's angle E. Which one matches with angle E? Angle E prime. Okay, so and angle E prime correspond. Let's do one more. Which angle corresponds to angle F? This one. Which one? Yeah, angle F prime. Okay, so I'm not trying to trick you. It really is that simple. Okay? Another way we could be able to tell is that when I'm listing it in the order, E and E prime are in the same spot. F and F prime are in the same spot. Okay? I'm not going to list all the rest of them. The other ones, G and G prime correspond. H and H prime correspond. So let's talk about corresponding sides. If I have side EF, here let me erase the angles. EF here, so segment EF, which segment corresponds with EF? E prime, F prime. So E prime, F prime. You have to put the prime on each one. So those are your congruent sides. Okay, let's do one more. What goes with segment FG? F prime, G prime. Okay. Question before I have you guys move on. Are the two shapes, the image and the pre-image, are they congruent? What do you think? How many of you vote yes, they are congruent? The whole shape. How many vote no, they are not congruent? How many of you have no idea? Okay. Why do you think they are congruent? They are. Why do you think so? Did the shape change at all? What's the only thing that happened to it? It slid up and right. Did the shape get bigger or smaller? No, so everything is still congruent, right? Okay, that's something that's important, and we will come back to it several times. Rigid motions preserve congruence. So the image and the pre-image are always congruent because rigid motion doesn't change the size or shape. Okay, here's what I want you guys to do. Do number 5 for me really quick. This one's a little trickier because it doesn't use prime notation. Okay, guys, I'm just going to do one or two with you. Angle NID is your original or your pre-image. Let's just do angle N. Which angle in triangle SUP corresponds with angle N? Angle S, good. And how did you know that? Who can tell me? Christian, how'd you know? Yeah. S and N are in the same side, and when we list them, they're listed in the same order, right? So the corresponding vertices are listed in the same order. So then let's do side NI. Which side is corresponding to segment NI? SU, good. Okay. So with our rigid motions, the first type that we're going to talk about today are translations. Okay. A translation is when we slide the pre-image either right, left, up, or down. Okay. So a translation, in the picture I gave you, we have square ABCD, and we moved it 4 units to the right and 2 units down. And so how they did this is they took point B, slid point B 4 units right, 2 units down, and plotted it. Then they took point A, 4 right, 2 down, and plotted it, and did the same for all of the other points, and that's how we got the new square, A prime, B prime, C prime, D prime. Now in math, of course, there are always notations of how to do these. So for a translation, we have 2 types of notation. Okay, we have coordinate notation, which is the rule that tells you where each coordinate goes. So for example, or not for example, this is for our example, we always start with x comma y. Okay, that's your coordinate. Okay, so this is telling me that for all x's and for all y's, the following rule applies. We use the arrow to say that it maps. And let's talk about the x's first, guys. In the example that they gave, how did the x's change? 4 units, which direction? Right. To the right. Okay, so in your coordinate plane, is to the right positive or negative? Positive. So our x is changed by adding 4. This is a test. You should not be getting help on a test. You move over here. What about the y? The y moved down 2 units. So when we're moving down, is that adding or subtracting? Subtracting. So that's your coordinate notation. So this is telling you that for every point x comma y, my x, I add 4, which means 4 to the right. And with y's, I subtract 2, which means down 2. Okay? Not too bad? Okay. So anytime you see something in coordinate notation, all it is telling you is how the coordinates are moving. We also have what is called function notation. And I'm going to do functions in blue. Function notation is a little trickier. Each rigid motion has a different letter that represents how it works. So for translations, it's a capital T. So for function notation, we notate that it's a translation by using a capital T. And then we use arrow brackets, which are the, I don't know, like the pointy ones, the less than, greater than looking ones. Uh-oh. So we use those little like bracket, they're not brackets, but they're like greater than, less than. But for translations, we still write it in the form x comma y. So our x is changed by positive 4, right? So we just put a positive 4. And our y is changed by negative 2, so we put a negative 2. So this means we translate positive 4 for the x's, negative 2 for the y's. That's what it means. Okay? But then you also have to say which shape we're translating. So in big parentheses, we say A, B, C, D. Okay? If it's a triangle, you put the triangle symbol. But for all other shapes, you just put the vertices. So this means we translate positive 4 for the x's, negative 2 for the y's, the shape A, B, C, D. And that's the function notation. So what we're going to do is we're going to do 3 practice And we're going to practice writing them in coordinate and function notation. Okay? So let's look at number 1, or 7, sorry. I have this shape, PQRS. It's a quadrilateral. And let's look at it. To get to P prime, Q prime, R prime, S prime, how many spaces to the right did I have to go? Will you count them for me? 8? Okay, so here's how we write it. X comma Y. Arrow. X plus 8, comma. And then this one looks like we went down. How many units down did we have to go? How many? 3? Melody says 3. David says 2. Now you guys are going to make me count. 1, 2. Okay, so Y minus 2. Parentheses. That's your coordinate notation. I know there's not a ton of space. Function notation. This is a translation, so big T. You're going to use your little pointy brackets. And we went 8 units in the positives, so that's going to be 8 comma negative 2 of, so big parentheses, PQRS. If you did a different order, that's okay. Oh. Okay. So now we're actually going to find the image. So they tell us what the rule is. We have triangle, I don't know, PQR. And we want to translate 2 units left, 5 units up. So we're going to go vertex by vertex. So I'm going to start with R. So I take R and I go 2 units to the left, 5 units up, 1, 2, 3, 4, 5. I put a point there and I label it right away, R prime. Okay. Then you do the same thing with Q. So we go 1, 2 left, up, 1, 2, 3, 4, 5. Label it Q prime. You must label. And then same with P. 1, 2 left, up, 1, 2, 3, 4, 5. P prime. And then draw your triangle. Oops. Okay. In coordinate notation, that would be XY maps to X minus 2, comma, Y plus 5. And in function notation, that would be T negative 2, 5 of triangle, what did I say, PQR? It doesn't really matter the order that you list them. I like to go alphabetical if possible. Me too. Okay, that's it. You're going to do this for 3 more problems. And that's pretty much your homework tonight too. Ooh, so that's translations. You're just taking a shape and moving it right, left, up, down. Okay?